All right, so what is an inverse, or I don't know why I have invertible function or an inverted function, but anyways, that doesn't actually need to be, that's worded wrong. That's worded wrong. What is an inverse? An inverse is a function that has had x and y swapped. That's all it is. You know, normally you give a function an x value, and what does it return? It returns a y. Now, an inverse swaps that around. You give it a y, and it returns an x. What's kind of funny is when we write them, though, we still feed them x's, but it's kind of understood that we're actually feeding the old y values. All it does is swap x and y, okay? And when you swap x and y, you swap everything.
Please pardon the interruption. At this time, we need our girls basketball players to come to the little theater for pictures.
Does that affect me at all? I didn't think it did. The domain of an inverse is the original function's what? Domain is x, right? Inverses swap x and y. So the domain of an inverse is the original function's range. We're swapping everything around. If it's x and y, we swap it. So the domain of an inverse is the original function's range. The range of an inverse is the original function's what? Domain. Because x's and y's do what? They swap. And range and domain are kind of concepts of x's and y's. Well, maybe so. I don't know. Does anybody remember talking anything about this in Algebra 2? Maybe, maybe not. The truth is, you know, most math classes move so fast it's hard to retain things. They really do. All right, so here's something else we got to add in. Only 1-to-1 functions. It's 1-to-1 functions.
Please pardon the interruption. At this time, we need the singers that are going to be doing the makeup ACT to go to the library, please.
I had no idea they were doing that today. Well, a couple of them are out for COVID. Oh, do you need to go? Yeah. Okay. You will not have a problem with these two sections, I promise you. Once you miss one or two, you'll figure out what you did wrong, and you'll figure it out from there on out. Only 1-to-1 functions or portions of a function that are 1-to-1 have inverses. Not all functions are 1-to-1, and you probably don't even know what 1-to-1 means. 1-to-1 is a solid relationship between x and y. You remember the definition of a function. Can an x have more than one y according to the definition of a function? Haley says Definition of a function says x doesn't cheat. Remember that definition? In a 1-to-1 function, neither can y. It's kind of like a marriage. X is married to y. Y is married to x. So only 1-to-1 functions have inverses, because if y was seeing two x's, how could you swap x and y? All right, well, let's do an example of this. Make a little table. Function. That's a function. Every x has one y. You agree? All right. Inverse. What happens in an inverse? What swaps? Swap x and y. So x becomes 3, 9, and 8. And y becomes what? 1, 2, and 7. That was easy enough. Because this thing was 1 to 1. It was 1 to 1 because each x had one y and each y had one what? X. So let's write that definition down, and I'll show you something that's not 1 to 1. And we'll just make it a short definition. Both x and y are loyal. They will not stray. They will not look at the waitress during dinner, okay, or waiter. They are loyal. I think every man alive is probably guilty of that. Don't judge us. We can't help it. We're horrible.
Interruption. At this time, we need freshmen, last name ending A through J, to come get your picture taken in the little theater.
What's wrong?
Last name A through J.
So here's a function. I'm going to make up something that is not invertible. It is a function because every x has how many y's? 1. Is it invertible? No. And the reason it's not invertible, you know, if you try to write its inverse, when you swap x and y, which x's are you going to pick? You know, you really can't swap it because you can swap this guy, 5, 1, that piece is invertible. But when it comes to the 7, which one's y going to keep? You don't know. That's the thing. You don't know which one is going to be the new input. You don't know that. So this is not invertible. Now, there's some more stuff about inverses that we'll talk about on Monday, but this is all we need for today. Okay? And really, truthfully, the only thing you actually need for today is that inverses swap what? X and Y. Okay? That's all they do, swap X and Y. And everything that I saw in the IXL section here says that the functions are invertible. All right? The functions are invertible. So the function f of x is invertible. Find, oh yeah, notation, f to the negative 1 is read as inverse of f. I just cannot write. I have never been able to write. It's ridiculous. I think after 40 years I'd figure it out.
The smartest people have that hand.
Well, I rush when it comes to writing. That and like in my head I'll spell the word, but I'll leave letters out. I don't get it. It's just the way it is.
The last letter off the word.
It gets worse and worse and worse.
And people that my sister can draw really good, and she has the worst handwriting. People that can draw good have bad handwriting.
Anyways, find the inverse for 44. All right, find the inverse for 44. Now, what I do is, this is the original function. contains negative 1644. All right, that's its ordered pair there, right? I saw 44, I looked for 44. You guys understand that? All we've got to do here is swap what? Swap x and y. So now we can take the point 44, negative 16. That means if I plug in a 44, what's going to be returned in the inverse? Negative 16. Now, I think I'll do the next one a little bit different to explain this a little better. Maybe it'll help. But that's the reality of it. All you got to do is look for the number and find the other one. That's all you really got to do. But I'll explain this one a little more clearly. So on this one, what I'm going to do, the next one underneath, is I'm going to create the table for the inverse, and then maybe it'll make more sense to you, I don't know. So I'm going to create the inverse table. So this first order pair, negative 6, negative 14, what's the row for the inverse table? This first row for f of x is negative 6, negative 14. What's the first row for the inverse table? Negative 14, negative 6. We just swapped these things around. The second row, negative 3, 2, is 2, negative 3. Third row, 6, 0. Fourth row, 10, 3. Last row, 26, 6. Oh, no, never mind, it's there. Our job is to find the y value when the x value of the inverse is 6. So what is the inverse value when x is 6? 0. And if you don't know what to do, you just fall back on the definition, swap x and y. That's all you've got to do. And I'm not saying that you have to do this when you do Excel. If it talks about f to the negative first of 6, you look at the y value in the table at 6 and you give the x value back because they swap input and output. So this will be the last note on, I think that's section A14. What is the inverse value of 69? $29. It's that simple. All right, so that's A14. I swear it will not take you more than 3 minutes to do. This is A15, which will also not take you more than 3 minutes to do. These are easy, easy grades. The function f of x is invertible, and there's a reason it's invertible, and we'll talk more about that later. Find the inverse value of negative 7. Now, when you're kind of looking at things like this, that negative 7, the way it's written, is that an x value or a y value? It's a y value. This is y equals negative 7 on the original graph. Does everybody understand that? That is y equals negative 7 on the original graph? Because they're inverses and they swap x and y. So all I do is I go to where y is negative 7 and I just put a point. That's where y equals negative 7. The ordered pair here is negative 1, negative 7. Now what do inverses swap again? So what is the inverse value of negative 7? Negative 1. And that's how hard A15 is. That's how hard it is.
Interruption at this time. We need freshmen, last name K through F. Come to the little theater for pictures.
All right, so why don't you guys spend 15 seconds of your life and figure out the inverse value of 5. Okay, you can have this copy. Make paper airplane out of it. Paper boat. I don't care. You guys figure out the inverse value of 5? I heard a 3. I have no idea. I never looked at it. So I saw 5, and again, this is a y value. This is mainly for Daniel because he wasn't here. Because that's given as an inverse notation, that's a y value. So I went to where y is 5. I put a point on the graph. And the ordered pair there is 3, 5. So I agree with you, Emma. Inverses swap x and y, the value must be 3. Anybody miss that? At all? All right. So I'll just call on some people for the next two. Asia, what is the inverse value when x is, when y, well, what's the inverse value of -3? So Asia says 9. Oh, I don't know why I put a point there. Am I stupid? That's the wrong place to put a point, isn't it? It goes right there. Remember, you got to swap things around. It's y equals -3. So there we are. We see that 9, -3, and I agree with Asia. It is 9. And the last one, because we're not going to talk about A16 today. When you get in the 90-point scale, what they do is they just throw a whole bunch of dots at you. I don't know why, but they think that's harder. We are tasked with finding the inverse value of a -10. All right? The inverse value of a -10. Savannah, I hardly ever call on you. What is the inverse value of -10? She says 1. I agree with her. Because that is 1 -10. You guys agree with her? That's 1. So anyways, that's all I'm doing today with y'all. I will not be here tomorrow. That'll give some of y'all something to do. Some of y'all are a little behind, so you really shouldn't be wasting time today. I did look yesterday to see what kind of progress you had. Most of you guys are in really good shape. There's a handful of you, 4 or 5, that are not in good shape. Well, like I haven't assigned too much. Well, I actually have assigned a good bit of stuff. It's all easy though. But like you've only done 3 or 4 things. You're probably one of them. I don't know.